The last transformation that we're going to take a look at today is the translation. And again, we did take a look at this rigid motion back in our translation or transformation unit, but we're going to look at it one more time just to make sure that we're okay and see how it works on the coordinate plane. So in the first exercise, we have line segment AB, and it's drawn and they give us the coordinates of the endpoints. What we're going to do is draw the image of AB after a translation 5 units left and 3 units up. We're going to label the point or label the image A prime, B prime, and we're going to list the coordinates below. So again, we're moving 5 units to the left and 3 units up. So we're going to take every point and move it 5 units to the left and 3 units up, and that'll be our A prime, and we'll do the same thing with B. 5 units to the left, 3 units up, and there's our B prime. And then we can just use our ruler, connect the two dots, A prime, B prime, and then it does want us to give the coordinates. So A prime ended up at the point negative 1, 2, 3, 4, 5, 6, 7, and then negative 1, 2, 3, 4, 5. So A prime is at negative 7, negative 5. And then for B, B ended up over here at the point 2, 1, 2, 3, 4, 5, 6, 7. So B prime is the point 2, 7. So now we're going to find the length of AB and the length of A prime, B prime using the distance formula. We have the coordinates for both or for all of those points. So what we're going to do is go ahead and use our big square root. And for A and B, what we're going to do is subtract the x values. So I'm going to do 7 minus negative 2, which is 7 plus 2. And then plus, I'm going to subtract my y values in the same order. So 4 minus negative 8, which is 4 plus 8. And now we just want to go ahead and clean that up. So 7 plus 2 is 9. Not a lot of room here. And 4 plus 8 is 12. And so we end up with 9 squared, which is 81, plus 12 squared, which is 144. And when we go ahead and we add 81 plus 144, we get 225. And then the square root of 225 is 15. All right, so we had to cram that one in there. That's a little bit tight, sorry. And then for A prime, B prime, we're going to do exactly the same thing. So we're going to find the distance from A prime to B prime. And so again, same thing. I'm going to start with my x values and subtract them. So 2 minus negative 7 is 2 plus 7. And then 7 minus negative 5 is 7 plus 5. And then go ahead and simplify. 2 plus 7 is 9, and we have to square that. And 7 plus 5 is 12, and again we have to square that. When we square both of those, we get 81 and 144, which is the square root of 225, and the square root of 225 is 15. All right, so what do you notice about those two lengths? They are the same. So it is, a translation is a rigid motion, which we've talked about before, because when we perform the translation, the image stays the same shape and the same size. So the distance from A to B is the same as the distance from A prime to B prime. All right, and now we're going to do the same thing with the slopes. So we're going to find the slope of A, B, and the slope of A prime, B prime. And for this one, I'm just going to count the boxes on my paper. Again, you could use the formula, but since we have a picture, I'm just going to use the picture. So to go from A to B, I'm going to travel up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units, and then over 1, 2, 3, 4, 5, 6, 7, 8, 9. So I traveled up 12 and over 9. And if I simplify that, I can take a 3 out of both of those. So that reduces to 4 over 3. And then I can check by starting at A and moving up 4 over 3, and I should hit the line every single time I do that. And I do. All right, so I'm going to do the same thing and find the slope from A prime to B prime. So again, I'm going to move up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and over 1, 2, 3, 4, 5, 6, 7, 8, 9. So same slope, up 12 over 9, which reduces down to 4 over 3. And so what does this result tell you about AB and A prime, B prime? Well, if lines or line segments have the same slope, then they are parallel. So segment AB is parallel to segment A prime, B prime. All right, down at the bottom, like all rigid motions, translations preserve shape and size. They also map line segments to other line segments that are parallel. So now we can combine all three of our major rigid motions, the reflection, the rotation, and the translation. So what we have here in the diagram, it shows kite ABCD, and that kite has undergone two transformations. Which sequence of transformations maps A, B, C, D onto A prime, B prime, C prime, D prime, and then it onto A double prime, B double prime, C double prime, D double prime. So we're starting here. That's our first image. We're doing something to it to move it to A prime, B prime, C prime, D prime. And then we're doing something to that one to move it onto the one with the double primes. So for this first transformation, we're basically taking it, we're sliding it over here. If we slide something, that's a translation. And then we're taking this one and we're turning it, and when we turn something, that's a rotation. So basically we're performing a translation and then a rotation. So a translation followed by a rotation, which is choice number 2. All right, so on the back, we're going to just remember that two figures are congruent if a sequence of rigid motions can be used to get one figure onto the other. So now with our coordinate geometry tools, we can use some of our rigid motions to describe this in more detail. So if we're given two different sequences of transformations that show that parallelogram ABCD is congruent to parallelogram EGFH, and what we want to do is be as specific as possible. So basically, we want to do something to this parallelogram right here to get it over to this one. All right, and they want us to do a sequence of two different transformations. So the first thing that I want to do is get this parallelogram above the line up here. And there's probably different ways to do this, but I'm just going to reflect it over the x-axis. So when I do that, C prime ends up here. D prime would end up here. B prime would end up here, and A prime is going to be there. So what I did there is a reflection over the x-axis of parallelogram A, B, C, D. And now what I have to do is get this to map onto that one. So I basically have to take it and slide it over here. But I can't just slide it, I actually have to talk about the coordinates moving on the x-axis and the y-axis. So I'm going to pick 2 points that match up, like C prime has to map onto G. I have to get that point over there. So I would have to move it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units, and then up 2. So the second sequence would be to translate every single point over 10 and up 2. And I'm going to do that to every single point on A prime, B prime, C prime, and D prime. And once I do that, then it will get this parallelogram on top of that one. And then I would know that they are congruent because they're exactly the same space. They're in exactly the same space. All right, so with exercise 4 in the diagram shown, we have triangle EFG, and it can be mapped onto triangle MNP using a sequence of transformations. If the first one is a clockwise rotation of 90 degrees around the origin, then what must the second transformation be? So they're giving you the first one. They want you to figure out the second one. So basically, the first one is a rotation 90 degrees clockwise, which is a negative 90, around the origin, and what we're rotating is triangle EFG. So I'm going to go ahead and turn my paper 90 degrees clockwise. And now if I look at EF and G, so point F is now over 3 up 1. Point E is over 3 up 1, 2, 3, 4. So I'm going to turn my paper back around, go over 3 up 1, and over 3 up 4. And G, when I have my paper turned, is over 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 1. So turn my paper back around the right way, and I'll move over 9, and up 1. And so I have G prime, I have F prime, and I have E prime. And so there's my little triangle. So now what I have to do is somehow figure out what it takes to get this triangle, E prime, F prime, and G prime, onto that triangle down below. And so it looks like it's a reflection, but it's not a reflection over the x-axis. It's a reflection over some line that's in the middle of those two. So if I were to connect those two triangles with a straight line, It looks like the distance between them is 1, 2, 3, 4, 5, 6 units. So halfway would be 3 units. So I'm looking at reflecting over that line right there. So that's a horizontal line that only hits the y-axis, it never touches the x, so its equation is going to be y equals -2. And so the first transformation was a rotation -90 degrees of triangle EFG, and the second one is going to be a reflection over the line y equals -2, and what we're reflecting is triangle E prime, F prime, and G prime. All right, and then the last one is just a multiple choice question, more of the same. So there's a sequence of transformations below that's used to map one triangle on the other. And so what they want you to do is just figure out what it is that they're doing to take one triangle and map it onto the other. So see if you can work through that one and figure out which sequence of transformations is correct there.